Audio check. 1, 2, 3. Okay, I think we're live. We're good. It sounds like we're on and we're ready to get going. So, ladies and gentlemen, welcome to the stream of the Discourager of Hesitancy. We are building a game with no game engine. We have minimal dependencies, 4 or 5 depending on how you slice it. And we're building everything else from scratch. And having fun and learning while we do it. I'm not an expert on any of this stuff. Just playing around. Ooh. I guess we technically got that done. I want to move this one over here into an off-stream task. Watching me open each audio file and trim leading and trailing zeros is not interesting. That's a very monotonous, boring, lame task, not programming related. So we can do that off stream. I think that's what we'll do there. We'll do this task today. Another thing we'll do is talk about where we left off yesterday. We have our audio coming in as dual channel 16-bit PCM. That's what we start with at 44,100 hertz sample rate. And we did some measurements, and the sound difference between left and right is negligible. So we get our first factor of 2 compression that way. We say this sounds the same with 1 channel as opposed to 2 channels, so we just made everything mono-channel. That would not work in a game where we have any kind of position audio relative to camera types of effects. So there's that. But we can get away with it this game because everything is very 2D and flat. So there's no real positional audio information. But then each sample in each channel is 16 bits. And that is a problem. Which brings us to mu-law encoding. You can take a 32-bit integer and turn it into basically an 8-bit float. And we looked at that. And it works. We can get it compressed, but there are artifacts in our audio for certain types of sounds. So short sounds with high pitch, those tend to have an additional like buzz to them when you go through the mu-law encoding. Other audio near the middle range of pitches doesn't sound that bad. And then we try to think of some other compression techniques we might use and really don't have any good ideas. So what I'm thinking currently for today is we can embed PCM, so pulse code modulation, and mu-law encoded audio. Play back either PCM or mu-law encoded sounds, and then test each sound in mu-law encoding and see which encoding to use per sound file. All right, hopefully that makes sense. Everybody on board with this? But we're still just doing one channel. Anything we can do to shrink our executable size and my code size, the better. So hopefully that is all clear. Also today, short stream. I've got to bounce out of here at around 3. I probably should put that in the Discord. By the way, short stream today, only about 3 hours. So, yeah. I have things to do, it's holidays. Let's move this back to to do for now. And let's get started. So where this all starts is here in EmbedWAV files. We're using this one, yeah, and the test and blah, blah, blah. Okay. So what we want is to do that, not that one. Upright variance. Let's mark out most of this. I would like to revisit this idea. Some of the other ideas have not worked out very well. So we're just, at this point, we're just measuring different things. I don't think we need any of those. We'll keep them around just for note. Max variance. So I think all that goes away, which means compression ratio, signal statistics. We're not really looking at this stuff right now. So there we go. I think, hey, Drovest, doing good today, doing good. We're back to audio. I kind of figured it would take me about 2 days to do audio, and today's a short day, so hopefully we can get it done. How's the game going? We're doing audio compression. We did a little bit yesterday. We'll try to get it done today, but it's going to be a short stream today. Yeah, we're going to do some space compression optimization. Use up your computer's memory more efficiently. And that's all going to start right here. Target equals embed wave files. And how are you doing, Droveth? How are you doing, LSI Kangaroo? Was it a Christmas dinner you're going to today? Yes. Yes, it was. Always gotta go to Christmas dinner. It's important. Yeah. I think we'll have a roast and some vegetables, and then I have to go to city council meeting after that, so kind of a busy evening. But last night I did make my last batch of caramel. Homemade caramel tastes so good. It takes like 3-4 hours to make, but it's so tasty. Okay, so we did that. .c tools bin / embed wave files. So we're just embedding mono-channel MuLaw encoded audio to get back to where we were yesterday. Oh, I remember you were talking about that. I remember you said something about transitioning some stereo to mono and some other strategies. Yep. Yeah, so we were doing some MuLaw encoded audio, and it doesn't sound great for some sounds. So we're going to figure out which sounds it sounds okay for, which ones it doesn't. And we'll use MuLaw encoding where we can. I'm doing good as well. Been planning some Christmas today. Good. It's looking good. Excellent. Yeah, so if we did all MuLaw encoded, our total compression ratio would be 25% because we drop a channel of data, cut it in half, then we take 16-bit PCM and turn it into 1 byte MuLaw encoded. That's another factor of 2, so that's 1/4. And we're talking 111 megabytes here. That's in our executable. If we can get it down under 50, I'd probably be happy, but I think we can beat 50. So there's that. We're going to sound and make sure that's doing what I think it's doing. Where's our MuLaw encode? So here's the changes and tests we've been running. Yeah, so we get the MuLaw encoded data there. MuLaw. And then I think there's one more place where we should. Magnitude shaping, if it's slowed down. Basically, whenever we get this. Okay, so everything here is MuLaw. Oh, histogram law? Yeah, we're not doing that. We're doing MuLaw decoded. Alright, so let's just try this file. We want this SoundWarehouse to be rebuilt. So yeah, if you have any questions about audio and MuLaw encodings, let me know. Happy to talk about it. Did a long stream yesterday. I think my stream today is going to be short too. Yep, short one today. Remember you said you were minimizing dependencies. Are you encoding and decoding the audio yourself? Yes. It turns out that 16-bit PCM is not hard to work with. So 16-bit PCM means you get integers, 16-bit integers signed. So from negative 32,000 to positive 32,000. And that's what we've been using. 16 bits is, 65,000 sample values, 65,535. When you go to MuLaw encoded, let's see here. I can show you what that looks like. It's not actually that hard. Embed wave files. Here it is. This is it. That's it. And I want to clean this up. I think we could do better. So, I mean, what is that? 15, 20 lines of code? I think we can make it better. And the decoding is pretty simple as well. Where's my MuLaw decode? Yeah, here it is. What is that? 12-ish lines of code or so. Piece of cake. Easy peasy. I watched a video the other day of someone parsing and creating a wave file themselves. It's really cool. Yeah, so that's what we're doing as well. So in our embed wave files, this is what the embed things do. It opens a wave file. So if we go to read, where is it? Read file. Give it a file name. Oh, not that one. Where's our data? Data. Yeah, so we verify the riff, we verify the wave, and then we start at byte 12, because that's basically where you have to start. Then while you're going, you read a chunk. So for every chunk, you figure out what kind of chunk it is. So if the chunk ID is something, that's a format or a data or something we don't support right now. We basically just need format and data. And if it's a format chunk, well, we say go parse that format chunk or parse the data chunk. So we get the format code. There's a whole bunch of them. We assert that we require the one code. We don't support anything else right now. We could. It's not actually that hard, but you know, keep it simple. We assert that we have a certain number of channels, etc., etc. Easy peasy. Returning the data chunk, reading the data chunk is easy as well. So yeah, reading a WAV file, the basics is not hard. Today's reason why OOP gurus suck. No, a lot of things people assume are very, very hard. It's just, no, you just got to go copy paste a small algorithm somewhere and then make it fit inside your code base, right? So yeah, reading a simple WAV file, not hard. Encoding your audio in different formats, not hard. Yeah. Nobody needs a big complicated library for that. And hopefully this week we get to start on compressing our image data. We're going to use a QOI format. Great. Okay, so in theory that finished the build. Okay, watch your headphones. It may be bad. We'll see. I think I've got everything put back to where it sounds okay. So watch your headphones. 3, 2, 1. Okay, I did not fix everything correctly. Sorry about that. The question is, what did I miss? Let's see here. Process our data. We get our left, we get our right channel. We measure the variance between the channels. It doesn't really matter, but it's fine. We only keep the left channel. We do PCM 16-bit to MuLaw, which is this one, and this one was working yesterday. So I think that's all correct. I think. We did run that. See, the maximum variance between left and right channels is tiny. It's not even worth measuring. So switching to mono is not bad. Which means I'm doing something wrong here in my sound processing. MuLaw data. We had this working at one point. So what have I done? MuLaw data is unsigned integers. That's fine. 8-bit integers. MuLaw decode. If it's not slowed down, this is what we do. Then we just always copy the left channel into the right channel. So what is this? MuLaw decode, our MuLaw data, and our mu sample offset. MuLaw decode. There's our bias, sign position. Yeah, I could clean this up. Well, we want to get rid of this eventually, but for now I just need it to work. So what's going on here? Histogram decode. So what's this mu law decode? Why is it not working? All right, you're gonna head out. Good luck with your stream, and yeah, we'll catch you on the flip side. Maybe see you tomorrow, since I'm probably not gonna be on when you're done. Have a good one. Let's see here. Process data. Maybe we should run that test block again. Let's see here. So we know certain values we can test. Build target equals EmbedWAVs. Run it. Oh, there is an error. That did not used to be an error. All of these values are correct, though. All right, where's all this tests? Oh, not that one. That looks odd to me. How can those two fail and everything else succeed perfectly? Unless where I got these values and it told me these are correct values you can check against. Unless they're wrong. So here's the 16-bit PCM value on this side. And here's what the output of my mu law encoding does. And here is the expected value. Expected mu law value encoding of 5 and 9. And that's just not right. Well, well, well. This was working yesterday, I swear. If we assume these are not right and everything else is right, then what am I missing? We're probably going to remove the A law. So basically, you use mu law for a better dynamic range, which is what we need. And A law is actually going to do worse than mu law in the end. Even though it takes up the same amount of space. But it does other things better. we want the dynamic range. That code was basically a copy paste. Interpolate between the two values, right equals left. That's if we're slowed down, so we shouldn't be seeing this anyways. This is the one that should fire. Left value, mu-law decode this data. Oh wait, I know what's going on. I know what's going on. mu-law decode. Pretty sure we have to do this. mu-law decode returns the 16-bit PCM value. I think we just need to divide here, here, and here. I think that's the problem. Yeah, so let's get it back to where it's working and get that committed, even though we don't like mu-law encoding for some of our sounds. And we'll get them both working. We'll clean up the A-law stuff. I was going to look up, I forgot to do this. Continuous discrete, blah, blah, blah. Oh. Let's see. Yeah. Okay. I think the build is done. So again, headphones warning. Anytime we're working with audio, I'll try to remember to give a headphones warning. Check. 3, 2, 1. Okay, so we're back to working state. Our audio works, but you can hear some fuzz in that whoosh sound. The door sound is fine, but there's that. The music, I don't hear any of that. That one has some artifacting going on there. B or Y? we put the abide. There we go. So like I said, some of the sounds are fine, like the rocket ship is probably fine. The archer. There's a couple of sounds here. Yeah, some of these sounds sound fine. Some do not. Okay. So we're back to running with Mulan encoding. Let's do a little bit of cleanup and that. But there are some sounds that definitely does not sound right. So let's get rid of... let's get rid of A-law decompress. The idea of this lookup table is great. We would like to revisit that someday, but we're not going to today. We're getting rid of A-law decompress. We can basically skip all the math and just do lookup. This one's fine. Magnitude change. Blah, blah. Where else are we? Okay. We could configure mono versus dual channel. That's a thing we could do. We won't use it in this program. Mono or stereo. So maybe we don't delete a lot of this code. Okay, we'll get rid of this one. Yeah, maybe we just have each sound able to be left-right channel. Yeah, I think that might be a thing we do. Okay. So there's that cleanup. EmbedWAVs. Let's go through A-law. Let's find all those. Oops. Let's just get rid of it for now. A-law compression table. PCM 16-bit to A-law. We're just going to ignore that for now. We have a test. I'm happy to keep that around. This is a... I think this is a cleaner approach. I would like to, but it didn't work. So I either need to go debug this some other time, or I need to port this more towards that shape. The algorithm is the same, it's just how you approach it. But I want more lookup table type things like this one. So we'll leave that comment in there. Which goes into our to-do list. Audio, improve mu-law encoding, decoding. We can add the option for A-law. Add A-law encoding. What else do I want? I mean, we should. We should do what? Let's just leave it there for now. Okay. But this works. So I think we are good enough. target equals and we aren't actually using this compression table. I don't think we're using this or that. Okay, so it's all clean. This all needs to be broken out and separated. So to do someday audio encodings in their own namespace or class or something. Okay, we'll come back around to that someday. Now, that's all fine. Journal. Okay. Added a safe code check-in with new law and mono audio working. Okay. Oh, after hours, I was playing around with drawing the plant some more. Nothing to show there yet. Everything else is sound related. Okay. Like I said, if we can get our current audio under 50 megabytes, I know I need to add more songs. And we will. But the better our compression is now, the better it'll work out. We commit -m. New law, encoding, and mono audio working. Okay. Now, over to our next task. So in the journal, we need to be able to embed either, actually, let's see here. Configure either mono or stereo. Per sound. That's probably the right way to do that. Like, if we literally just did mono PCM for the 2 long songs, that's already a huge win. But if I can set it per sound, then it's more control, right? Playback either mono or stereo. Okay. All right, so let's go to embed. This is where the first thing has to happen. When we read this sound definition, we need to know bool is mono and bool is... Oof. If we want to support more in the future, we just need to do this now. Enum class encoding PCM 16-bit is the first one. New law will be 1. We'll, it doesn't really matter at this point, equals 2. This is the embedding. Blah, blah, blah. Then we need encoding. Okay, so where we read the sound file, we expect a key, a tag, so that's the volume channel that we manage things on. It's baseline volume, scaling, to do pre-apply the volume. We can add that to our to-do list as well. Maybe we just need a broader audio channel task. These are things we'll want to fix up later, but we don't need it to be perfect before release, just good enough. Okay. Audio. Pre-apply per sound volume during embed. Sure. Okay. Okay, so key file tag. We need channels, and we need encoding. Probably after tag. Encoding the channels. Sound definition. So we have to actually do some processing on that encoding. We're not going to do anything with it yet. We just want to make sure it's read in from the file correctly. Yeah, we need to do better sound file parsing eventually, but that's way down the road. That's like definitely between project stuff. So it's key tag encoding channels. Maybe do that after volume. We're going to do encoding, then channels. So let's do mu and mono. There's the main idea. Hey, thanks for the follow, No Land Dev. How's it going? How's it going? Welcome to the stream. Today we are trying to get multiple encodings supported for our audio files. I have a question. I'm studying Python to get in backend or data science. Are there good job opportunities currently with Python? Yes, there are. Yeah, there are jobs. You're looking mostly at AI and data processing, image recognition, AR, VR, like the, yeah, just a lot of data processing is happening in Python these days with SciPy, NumPy, Scikit-learn. Yeah, you can get jobs in Python. Yep. Yeah, I get hit pretty often with things in job lists for Python, data, AI, training, all that kind of jazz. Big companies want to train their AI models faster and harder. All right, so I'm going to start comp encoding with something, if that's 0. And our 3 supported encodings are PCM, mu, and A. For now. PCM. Mu law. And a law. Let's put a go. Yeah, let me know if you have any questions. Right now we're doing a game with no game engine from scratch, C, C++, minimal dependencies, 4 dependencies or 5 depending on how you slice it. That's all we're allowing ourselves. So if you have any questions today about encoding audio, I'm happy to dive into detail on that. I have other things we can talk about as well. Just let me know. Otherwise, I kind of just tend to code stream of consciousness while I work. X, Y, Z, what did we even call it? New law, a law. Okay, I think that's basically it. Otherwise, oh wait, we do want those all back into it. Done because of that else. Error. Unrecognized coding. Defaulting to PCM, which probably is not right, but you know what? Kind of doesn't matter. So that's the encoding. The other thing we need is mono. Hey Pat, what's up? What's up? We're good here. We're good here. We're making it so we can encode our audio in different ways. PCM 16-bit. It's what we've been working with forever. It takes up too much space, but it's good quality audio. We're shrinking it using mu law encoding, but it doesn't sound good with every sound. So we're now switching over so we can use either one. Enum class channels. We want mono and stereo. That's basically it. Oops, let's see here. Channels. So we'll be able to, per sound, choose how many channels it is and what encoding it is. What have you been up to, Pat? How are you doing? Read in channels. guess we default to stereo. Then we're looking for stereo. Or mono. Channels is stereo, I guess. Unorganized channels. Defaulting to stereo. Stereo and mono. Okay, then our structure is volume, then channels, then encoding. Volume, channels, encoding. I think that's that. Just trying to get through the holidays, start the new year with a different mindset. Yep. Nope. January is a good month to restart. Definitely. I think a lot of people can use a bit of a mindset change come January. I think a lot of people are just tired, and there's a lot going on, and just life doesn't let up. There's always something going on. What was it? Was that a Robert Frost quote? Robert Frost said something like, I can, in 3 words, there it is, that's the one. In 3 words, I can sum up everything I've learned about life. It goes on. That was Robert Frost. Good job, me. It just keeps going on. It's actually one of the things I really liked about the confusion. What? Oh. There we go. Okay, indent. About the Once and Future King by E.B. White. There's a whole passage about growing older, and you just have to live it, right? There's no way to explain to younger generations life. You can tell them in words, but it's not the same thing as just aging, right? I think that was in book 2. Let's see, there's The Sword and the Stone. I don't remember the others by name. End of book 2, beginning of book 3, and that's... I don't remember. Yeah, okay. So we've got our sound definition channels, then encoding. We read encoding, then channels. Maybe we flip that so I'm just consistent. Encoding, then channels. Encoding, then channels. Okay, so let's just try this. PCM is not a member. Are you kidding me? Oh, PCM 16-bit. Yeah, let's just get rid of that. Incompatible types. Channel equals. I agree. There we go. Okay, now when we run this, we won't expect anything different from usual. That's fine. Then that's part one. So down up here in process data, here's the problem. It's not really a problem. Where is our sound definition? Right sound source. Name, key, tag, volume. See, all this should just kind of be part of. Should just pass the sound definition itself. Huh. File name, class label. Fine. We don't need size mode. Oh. Embed sound function. This is what we want to change. File name. Key tag volume. Let's see. Don't need width and height. Don't need width and height. I feel like something's missing there. Don't need width and height. That's a copy paste thing from elsewhere. Size. Where did size get put in? Okay, that fixes parts of this. Right sound source calls this function out file. Where is out file? Function out file index. F name is Okay, but this, let's just change that. Key tag and volume should just be a sound definition that's going to complain. Process data, sound definition. Okay, for now that's fine. Compile. It's going to complain about a bunch of things broken. That's okay. We need to declare our sound definition way earlier. It goes to the top of all things. Okay. Key is sound definition.key. I think we want to take pointers. Okay, this one, key sound definition. Okay. File index, file name, sound definition. Oh, size. Yeah, so width and height go away. Right. Convert const char star in argument passing. So key tag and volume. Hmm. I think all we really need to do. pass the file name, right? So that also comes out of files index. So it's files plus index. That's really all we got to do there. Let's see. That's simpler. So I'll complain about other things. Like this part. File name is just sound definition, point to file.cstring. All right. With the address of this file. All right, now we're getting close. Constitute function. Okay, so function requires that this be a const. Pointer. Should be okay with that. Yes, yes, I know. Temp width and temp height don't matter anymore. Name. Undefined reference to right sound header. File class define entry count and then the bunch of files. Size mode doesn't matter anymore. Heyo, that's done. Cool. All right, so let's do this. We're going to just run it, see what happens. Okay, I don't like this happening. I'll just these samples. Sound definition key.cstring. Okay, and in theory, every file is compressed by 25%. So if we come in here to process data, this is where we actually need to get to. We get left, we get right. Compute the variation, sum of squares, etc., etc. Kind of ignore that. If what's it called? Sound definition. Sound definition channels will do one thing. Otherwise we'll do something else. Oh, this is interesting. Okay, result. I remember what we did before. Oof. Yeah, this is getting a little bit funky. Because the next thing is, for each of these channels, you know how to encode it or not. So I'll create this result. Compressed size. Our compressed size depends on how many channels we're sending, one or two, and our sample size, which is our encoding. So we start with a frame count, which we need somewhere anyways. Frame count. That's our input frame count, right? So our compressed size output size equals frame count times I think this is going to become a bit messy, but not too bad. Sound definition, encoding, No. Let's do it this way. Bytes per sample equals 1 if sound definition encoding is equal to encoding PCM and bytes per sample equals 2. Then we do something similar with int samples per channel per frame equals 1 if sound definition channels equals stereo, then our samples per frame equals 2. Then we can compute our output size, which is our number of frames, times our samples per frame times bytes per sample. So that's how much room we have to allocate. So our compressed size will be output size. Then we allocate the memory. Our input data is always PCM because I've declared it to be so. This PCM sample count, this frame count, we've already computed above. PCM sample count. I'm not sure we use that anywhere, do we? There we go. Required sample size is 16 bits over 8 bits per byte, so we get our data size in bytes. Okay. That all makes sense. For each of those, measure some stuff. That doesn't really matter. Here is where things get a little bit interesting. And it gets weird enough that I may break this out into a function. So our result looks like that. So let's do void encode destination buffer return the offset into it. Destination buffer, we need to add int 16 PCM sample. Then we need these. We just need the encoding. Okay. encode into results. Let's see here, I need an offset. Result plus offset is where we're going to write to. We need the PCM sample. Then we need sound definition encoding. I think that's it. We encode the left and the right. Encode. The encoding case. We deleted a law encoding, I'm afraid. Encoding PCM. New law. A law. Let's do this. We will lie. All right, so we take our destination, cast it to int16t pointer. Contents of that will equal our PCM sample result equals 1 byte, I guess. Turn the result to, there we go, that's better. Otherwise, destination equals what is it called? PCM bit to mu, 16-bit to mu law. I think we deleted all the A law stuff. And then we write 1 byte out. Okay. Encode here to the offset, this thing, this 1 plus 0. Is that going to work? It didn't crash, or at least it compiled. So everything should compile, we get 25% again. That slows down our processing a little bit, but I think it's okay. 50%. Why is that? Mu law mono. Okay, we have an issue somewhere. We have this many input samples, which means we have this many input frames. 1 or 2 bytes per sample, 1 or 2 samples per frame. We have this many frames, we have this many samples per frame, we have this many bytes per sample. These all should be mono and mu law. We got our PCM data. I ignore all this. If it's mono, we only grab left channel. Otherwise, we grab left and right channel. And do that. Confusion. Confusion. Unless I'm doing something weird. Coding. Huh. Total bytes of data divided by 2 bytes per frame count. Compressed size. Frame times samples per frame, should in this case be 1. And the bytes per sample, which should be 1, which should give me a total number of bytes. Right. Mono. Not mono. Through each frame. Yeah, these are half. Why are they computing half? Is there something I don't understand here? Unrecognized encoding, mu law, defaulting to PCM. We just need to scroll up higher. String compare. Mu law. There we go. Capitalization errors. Always fun. There we go. There's our 25%. So if we went in here now, we should be able to change all mu law to PCM and all mono to stereo. Run it again. And we should not see any compression. %. It should not be any percent. Okay. Hit PCM stereo, right? 2, 4. A required input sample size of 2 bytes. 16 divided by 8 is 2. So we take our data size and cut it in half. Require 2 input channels. So we chop it in half again. But we should then be multiplying by 2 and then by 2. So our frame count times 2 times 2 should be the same as this data size in the end. But it's not. That's very bizarre. Okay. Oof, I have to remember I don't have all day to do this either. Although I think we are close. The end of all this, assert that our offset times bytes per sample. Our offset equals our compressed size. I think that's a good thing to do. Wouldn't be at all compressed. So what are we getting here then? Oh, yeah. Processing. Frames. Is frame count. Let's see here. Input size. Is our data size. Frame count. Okay. Bytes per sample. Samples per frame. Out size. It's saying one sample per frame when I say PCM. Oof. Samples per frame is one. Oh. No. That's stereo. So it should be two. It does not say mono. That does say stereo. Oh. Oh, goodness. Okay, well, that's an easy fix. That there's just being stupid. Okay, so that's going to be better. Okay. Now there should be no compression. Yeah, looks good. Okay. Phew. Good. Okay, now we're going to change all stereo to mono. We're changing all PCM to mu law for now. That will be a big part of our thing here. Now our sound file needs these as well. And we'll need to turn out audio encoding stuff somewhere else. But for now, we're just going to put it in here. Sound.h. There's a waveform. Channels and encoding. Stream volume frequency. All right, we need to change new data to just data. and new sample, just sample. Okay. And lastly, we need encoding equal to something, encoding and channels. This basically only relates to, yeah. Init sound. Data. Signal data dot encoding equals encoding PCM and channels will be stereo, just by default. Set file. Dot encoding channels. Get from SoundWarehouse. Okay. So back to EmbedWAVs. We've got the volume per. Get volume. M_volumes. Okay, it's a small change of mind here. Channels and encoding. This goes into the SoundWarehouse. Okay, now when we write out this file, enum class asset. Print f out file. Channels and encoding. Then we dump the assets. So that's easy enough. Now get volume. Not that. Float, we want encoding. Get coding. Channels. Get channels. There we go. Then for every volume, we need an encoding. Encodings and channels. Get volume. basically it. There. Encoding with channel. Get encoding at channel, get that channels. Then this stuff. All right, we're getting close to having this kind of work. Entry encodings. Modulus S encoding. Encodings. Modulus S, modulus S. Okay, files index. Volume is not correct. Encodings, comma, and then the name of the file. So, encoding. Oops, encoding. Case. Encoding is PCM. So we need the class label. Then the thing, PCM. Then break. Okay. New law. Yes. A law and a law. Okay, entry encodings. Then we need the same thing for channels. There are only two. Channel mono and channel stereo. Does that just finish off what we need here? Channel has not been declared. Okay, I guess that makes sense. Okay, we run this, and in theory it doesn't crash. In theory, that gives us all the information in our SoundWarehouse. I'm not going to open the C file. Okay. Let's go take a look at this. Okay. A bit of tidy up here and there. Okay. Get encoding, get channels. Let's just try this. -k tidy debug. And we see what we get. Okay, have some issues. Sound. Sample count. Oh, I see. Okay. Let's go back to... Oh, darn. Changed sample count from new data. Okay. New data to data. Agreed. New sample things. Do I not use mu sample count? I do use mu sample count. How is that different from sample count? We don't. Interesting. No, surely that's not right. Count. When we set the file, oh, well, that's definitely got to change, doesn't it? You compute from encoding. I have to do that. To do compute from channels. Okay, so that sense sample count is the total number of samples in the thing. When we reset, this used to be mu, so it should be data sample count, data sample offset. Which means sample offset, we should be able to replace this everywhere. That doesn't collide with anything, but dot sample count should be set here. Initialize the sound is fine. Data sample count should also be 0. Except max samples data sample count. It's actually kind of unused, isn't it? It's always compared to max or this one. Dot sample count. We do merge with above. I don't think dot sample count is actually I don't think I need either one. Samples equals 0, I think. Data sample count. And it's gone. Okay. Let's see if that works for us. I searched for dot. Dadgum. So our sample count is our actual data sample. right? Because we add the sample count. Okay. Sample count. Init sound. Single data sample count equals 0. Set file. Sample count equals 0. And reset. Data sample offset. Sample count equals 0. I think that's it. Sample count. That fix everything we need. All right. Okay, when we do get channel, target equals EmbedWAVs. Re-embed our waves again. Oh, I hope I didn't break too much there. XP sound. Okay, tidy, debug. Okay. Now in theory, it's not too hard for us to completely switch from fully compressed to uncompressed. We do have this thing here. Int with onsite data sample offset. Let's see if we can make that stick. All right, just cranking through. And hopefully we didn't break sound. This is all the mu-long encoded stuff. Okay, file. Sound rebuilt fine. SoundWarehouse is rebuilding. It's not crashing. That's encouraging. And since it's only a million lines of data, shouldn't take too long. Channel. I thought I fixed that. Oh, there it is. One we missed. EmbedWAVs. Okay, so I think we're just about there. tidy debug. That'll take a minute. We should have no more errors. Let me see if we can still hear what we expect to hear, given mono MULA encoded data. SoundWarehouse takes a minute. Oh, well, there we go. It broke. Oh, good gravy. All right. EmbedWAVs. Yes, kill it. Run this again. Then tidy and debug. Just working our way through some code generation issues. Hit the SoundWarehouse eventually. There it is. Now we wait for a minute. Hope no errors pop up. We're probably not gonna have time to get this all done today. Not done. Short stream today is gonna be a little bit crippling. Oh, that didn't take long. That was pretty good. Okay. Crank through everything. Oh, goodness gracious. Oh. Almost through the doodads. Final binary executable linking. Oh, it finished. All right. As always, headphones warning. In 3, 2, 1. All right, we didn't break it. Sound is okay. Great. Okay, I think we're good. We didn't break it. Now, last piece of this puzzle is we have left-right processing if we're stereo or not. So we have some to-dos here. To-do. Oh, the total number of maximum samples depends. And then our duration is the number of frames. So our size in bytes. We also need to get this encoding and channels. So SoundWarehouse, get encoding for the asset. Guess we can use that. That's fine. the channels. You can get the volume any old time. Maximum samples. Okay. Switch m_signal data dot encoding. So if case SoundWarehouse encoding ECM, we're gonna do one thing. U log and A log. These will be corrections to, I guess, just max samples. Okay. Number of samples. Signal data dot max samples divide by equal to, or just divide by equal to 2. These don't make any difference. They're 1 for 1 byte. Okay. Next. This, I think, goes in set duration. So we compute a duration, and if we are in stereo, we're gonna say our duration gets cut in half. Okay, then not the last piece, but pretty darn close. There's the stereo version, here's the mono version. Channels. stereo. And we go through all that and break. So here's mono. Oh. Okay, this gets a little bit messy here. Got 40 minutes to hammer this out. PCM data is now uint, right? Or that's not called PCM data. It's called comes into the mono processing line. This is all in the stereo processing line. Okay, so there's one chunk. I don't like parts of it. That's okay. So we're going to wrap up this and this into a function. So we'll get to that in a minute. We get our indices, we get our samples, update our sample counts. So this is mono, this is stereo. Okay. I think that's most of that processing line. So this is the are we slowed down model. All right, switch mono and stereo. I didn't realize I was going to have to maintain both branches of this. So. We don't like that one. Okay. For sine, square, etc. generated, then we sample, that's all fine. Everything else outside of here should be fine. Yes, yes, yes. Okay, that leaves us with the question, I think, of this versus this. So I think what I want to do is write a little helper function above here called static float sample, and we're going to take in our data, this thing, on offset, is actually this. We're going to take data sample offset. We need to max samples. Why don't we just actually pass in our signal data? That's probably easier. It's gonna look like double? Okay, fine. Either this thing or this thing. Switch data. Where is that? Data sample offset. Sample number. Sample index. Sample index. Yeah, that's probably the right way to do it. Encoding. SoundWarehouse encoding. PCM. One thing. New law. A law. So I guess int 16 sample equals 0. Sample over 32 whatever. Sample equals that thing. Or sample equals that thing. Okay, I think that simplifies things a bit for us. Result. Okay, last piece. Int 16t pointer cast this thing at sample index. Sample index. Okay, 32, whatever. Let's do this. We're going to sample our data at previous L offset. Sample our data here. If it's mono, if it's stereo. Sample data here. Sample data there. Sample data there. Sample data there. Okay. Then here, more of the same. Data there. Sample our data here. Sample our data here. See how that rolls. There is a good chance that I've broken things in all of that refactor, but it's not too bad, I think. And if that one works, our next step is to run everything with everything decompressed. Oh yeah, we have some out of date things that we let roll through. Yes, data was not declared. Blah blah blah. Blah blah blah. Sample cannot be used as a function. Sample data. Let's see here. Get sample, I guess. Okay, so we can get a bunch of stuff in sound still, but it's much closer. So this one looks like that. jump to case label. I don't see any particular problem with this. Oh, process initialization. Fine, let's scope it. Don't like it, but this is not how I would have designed the language. Unused variable t. What? I'm pretty sure that is used. It's not used. That only matters for this interpolation, doesn't it? If it's slowed down, compute t. There we go. All right, getting close. Last few things here. Okay. Hey, Dravest, thank you. You have a wonderful evening as well. I will see you tomorrow. Okay. For everybody else, headphone warning. We're going to test again. 1, 2, 3. Ah, I don't think I broke that much yet. So this is all new long encoded mono channel. Okay. It's running. Okay, one more check. And this is the bad one. Sounds.tech. We're going to change all new law to PCM. We're going to change all mono to stereo. So no compression. Re-embed all of our data with no compression. Just to be sure that we can run 2-channel, 1-channel MULA and PCM encodings. This one will take a while. We're going to get through all of this audio. I think while that's going, I'm going to heat up some more water. So I'm gonna go heat up some water for yerba mate. I will be right back. Okay, we are back. And I got back before the build finished. Not bad, not bad. I'm out of kernel though. Probably for the best. Need to leave some to get dipped into chocolates and some to wrap in Panucci logs, caramel Panucci logs, yes. So good. Build is almost done though. All right, time to test. Just getting my gum lined up here. Got a bunch of different flavors. I find chewing one flavor of gum just, it gets so old. Okay. Okay, now warning. Headphones people, this might be loud, might not. We'll see. It's here's hoping. 1, 2, 3, go. Okay. It's not, but I am listening to things out of only my left headphone. And therefore everything is playing at half speed. That's unique. Okay. That's not as bad as I thought it would be. Set file, encoding and channels. think we're so close. If we're in stereo, it's half as long as we guessed. Okay. There are a couple of things here. Okay. Okay. Here's the trick. Set duration has different things going on here. If signal data.waveform equals sound waveform none, then we do that. Otherwise, we do this. And either way, we set that. I think that will fix it. Let's see how that works. Nope. Still have coding PCM. All right. SoundWarehouse get key of underscore signal data dot sound index. All right. PCM stereo, wrong. But it's logging the right stuff. It's not playing the right stuff. Sample offset, data sample offset. Sample count. I think we're getting back into a situation of sample count. As opposed to sample offset. Let's try that. All right. Should have been more careful when we introduced mono-channel processing to keep that stereo running. No, it's too fast because we're stepping through the bumpers too quickly because we are doing a data sample offset increment where we shouldn't. Here we do a data sample offset increment. here we do one. But I think we do them here, that's fine. This I don't think we do. I think that's the problem. Got an extra index increment, or we shouldn't. Hey, it sounds right. Comes in both headphones. Sounds like it's running about the right time. Okay. So PCM stereo works fine. All right, now we've got both of those running. I think we actually do not need sample count. I'll bet if we run this, the only references to it are assignments. And we never look up the value. All right. There are definitely things we can do to make it better, but it's good enough. All right. So we've got that cleaned up. And we can commit this. We can now run mu-law encoding monochannel PCM stereo. So in just in time too, it's 3 o'clock. Going back to sounds, we're changing all PCM back to mu-law. We're changing all stereo back to mono. Okay, we're doing a quick re-embed of all of our compressed data. Even though it doesn't sound as good. Rebuild everything. And make one last test run of this before we commit. Call that good. I'm going to start pre-writing our journal entry for that. Okay. SoundWarehouse now contains channel count info and encoding info. Embed can do either PCM or mu-law. Sound now can play back different encodings and different channel counts per sound. Let's see how the build's going. Getting close. Then I gotta scram after this test. This is good because tomorrow we can pretty quickly, I think, blaze through all the sounds, see which ones have to be mu law and which ones we can get away with. We have to use stereo. Write that into a data file and we're done. We'll see how much we actually save when all is said and done. There it is. The mu I can hear, the mu law encoding artifacts. So it is playing and it is working. Okay. So I think no T, it is C or H, it is not N, therefore it's H and not C. And then we just fail out. And exit. Okay, I think we're done. That looks and sounds pretty good, and we have lots of flexibility now with our audio to compress what we need to compress. So I think we're in good shape. All right, now I have doubts. I want to watch that latest replay. We're going to speed up. Audio still sounds fine. Okay, I thought it would work, but I wanted to be sure. Okay, so I don't think we broke time-scaled sounds. I think we're good. Git commit-m, sound embedding and playback, and work with 1 or 2 channels, and PCM or mu law encodings. I think that's it. We're good. We're done. So thank you for joining me. I'm going to go head off and find myself a Christmas family dinner. And tomorrow we'll hammer the last bits of this little task out. And sound will be as compressed as we're going to get it this time around. You have a wonderful evening, and I'll see you tomorrow. Bye-bye.